Welcome back and thank you for joining. In this part of the lesson, we'll practice how to convert exponential numbers with rational powers into radical form and evaluate them using a calculator. So recall that the formula that connects an exponential number with exponent in rational form and a radical number is a to the power of m over n is equal to, so remember the presence of a fraction indicates that we have a radical. The number in the denominator becomes the index, and the rest of the number, let's say a to the power of m in this case, will go inside the radical, which we call a radicand. So we'll take a look at example A, where we have negative 8 to the power of 4 over 3. We'll write it first in radical form. Again, the presence of a fraction indicates that we have a radical, and 3 will be the index. Negative 8 to the power of 4 will be the expression inside the radicand, or the radicand, the expression inside the radical or the radicand, and that's what we obtain. So another way of writing this same number would be as the third root of negative 8, and we can write the power of 4 outside the radical. It has the same value and the same meaning. So next, we will evaluate 3 to the power negative 8 to the power of 4. So I wrote just 2 in here, and that's because negative 2 to the power of 4 is equivalent to positive 2 to the power of 4, and the answer would be 16. And let's move on to question B. So in question B, we have 81 to the power negative 3 over 4. So this is a little bit different. As you can see, the exponent is negative. And if you recall from prior grades, the teachers always emphasize the fact that an exponential expression or term or number is considered to be in the most simplified form when the exponent is positive. So we have to convert the exponent into a positive number. And now we'll see the reason why. We want to convert this into radical number, but having a negative exponent in here would make it a little bit more complicated. So it is a lot easier to convert this into a positive and then convert to radical. So again, fraction means we have a radical, 4 will be the index. Therefore, we have, first of all, 81 to the power 3 over 4, so exponent converts into positive by flipping the number. And we have the fourth root of 81 to the power of 3, and that will be similar to or same as the fourth root of 81 to the power of 3, with 3 being outside the brackets. So then we have 1 over the fourth root of 81 is a 3 to the power of 3, and that would equal 1 over 27. So let's take a look at another example, very similar to the previous one, but this time instead of a base with no fraction, we have a base in fraction form. And actually this makes things a little bit easier for us because we can now see what the numerator and denominator are. So we'll take care of the negative in the exponent. So for this, we'll have to flip the base. So from 25 over 4, we'll write it as 4 over 25. And the exponent will change to positive. Now, always remember, flip the base, change the sign of the exponent. And a common mistake people make is they flip the exponent as well, especially when in rational form. And I don't blame them because it is very tempting. But please remember the rule that we flip the base, we change the sign of the exponent. Next, we will try to write this in radical form. Remember, fraction indicates the presence of a radical, means we can convert to radical. The denominator is the index. I'm writing this down in here, but we don't have to write the index when the value of it is 2, and that is because 2 is the smallest index that we can assign to a radical sign or radical number, and as such, we've given it the honor of not writing it at all, but it is the index of 2 when we say square root, and then inside it, we're going to write 4 over 25 to the power of 3, and that will be the radicand. So another way of writing this would be the square root of 4 over 25, all of it to the power of 3. So again, as we mentioned in the previous examples, if you keep the power inside the radical or outside it, doesn't really matter. It is not part of the base, that's why. So it's powers working together, okay? So it's the same as if saying 1 over 2 times 3 or 3 times 1 over 2 when it comes to radical numbers. So next, we will rewrite this as 2 over 4 to the power of 3 because it's easier to evaluate it in the with a simplified base. So the square root of 4 is 2, the square root of 25 is 5, and 2 over 5 to the power of 3 would equal 2. Remember, we apply the power to both numerator and denominator. So that's 2 to the 3 over 5 to the power of 3, and that would be equal. 2 to the 3 is 8, 5 power 3 is 125, and voila, this is the answer. So in the next examples, we have to use a calculator and evaluate the following numbers to the nearest hundredths. So we're starting off with example 3a, where we have 2 to the power of 3 over 3.5. So in the first step, we have to explain how we'll use the calculator. So first, we're going to start with typing the base 2, so type 2. And then next, we have to type the power button. And in some calculators, the power button appears with this little hat, in some with y to the power of x. Please get to know your calculator, how to use it so that it won't be confused during the test. So next, we have to type the number or the exponent 3.5 and press enter or the equal symbol, and then you'll see the answer. And in this case, the answer that we obtained is 11.31, rounded to 2 decimals. Let's move on to our next example. This time we have 7 to the power of 2 over 3. So while the previous example had the power as a regular number, so to speak, here we have an exponent in rational form. And this is where the story will change a little bit in how we calculate it. Now remember, we should not divide 2 by 3 and round it to the nearest whatever decimal, because that will distort the value of the number, and we won't be able to get as precise a number that we should. And remember that rounding the powers can be a tricky business, because the powers, a small change in the value of the powers, so generous rounding, in other words, can affect the value of the number tremendously. So how do we use the calculator in this case? It is pretty much similar to how we use the calculator for the previous example, with only one small little addition, or detour, I say. So first we have to type the number 7, that is the base. And next we have to type the power button, or the y to the power of x button. Now this is where the story will change slightly. So in order to enter the power of 2 over 3, it is important that we keep this in brackets, because the calculator won't recognize the bedmaster rule otherwise. So we have to type brackets to keep the power that is in rational form in brackets. So press 2, press divide, press 3, close the brackets. So again, the reason why we want to do this is by keeping 2 over 3 in brackets, we are telling the calculator that number 7 is raised to this power, 2 over 3. If we do not include the brackets, the calculator might go crazy and bring 7 to the power of 2 and then divide the entire answer by 3, which would lead to the incorrect answer. So once we do that, simple, we just press enter or equal, and we'll get the answer. And the answer in this case, rounded to 2 decimals, is 3.66. One more example, we have the third root of 15. So again, we're going to rewrite this in exponential form. It is a lot easier to write numbers in exponential form because calculators are limited when it comes to the index. So most calculators will have the square root and the third root, but they do not have roots higher than index 3. So, and that's why it's useful to go over an example where we have to where the calculator provides the root, but we also apply or practice with the rational form of it, so we can see how it works correctly both ways, right? So 15 to the power 1 over 3, again, we're using the same strategy as in the previous example. So we are going to type the number 15, we're going to type the power or the y to the x, whichever your calculator has, and then we're going to keep 1 over 3 nice and warm inside brackets. So we'll have to press 1, divide, and then 3 and close brackets, press enter, press equal, and voila, you'll get the answer of 2.47. And lastly, we have example D. We have the square root of 29. You can easily do this by using the calculator. I'm going to use the powers because I want to practice them, how to use the calculator to evaluate exponential numbers with rational exponents. So again, type 21, type power, brackets, 1, divide, 2, close brackets, and then equal or enter, and that will give us the answer, which is 5.36. I hope this made sense, and I hope you found this entertaining, actually, because it is kind of fun. Thank you for learning with me. Bye for now.